Good morning, students. Let's continue the discussion. Today is also discuss some more problems and about the adjoint and inverse of a matrices. If A equals 3 minus 1 2 2 and B equals 1 minus 2 3 0, then verify that AB whole inverse is equal to B inverse into A inverse. Now first we will consider A into B, one part of the LHS. Now elements of A 3 minus 1 2 2 into elements of B 1 minus 2 3 0. So first will these two are get multiplied with each other. In first row, first column 3 into 1 is 3 minus 1 into 3 is minus 3. Again first row second column 3 into minus 2 is minus 6 minus 1 into 0 is 0. Now second row first column 2 into 1 is 2 plus 3 into 2 is 6. Second row second column 2 into minus 2 is minus 4 plus 2 into 0 is 0. 3 minus 3 is 0 minus 6. 6 plus 2 is 8 minus 4. These are the elements of AB. Then now to find the elements of A inverse. So what about the definition or formula for A inverse? A inverse is defined by 1 over determinant of A into adjoint of A. So according to the formula, now AB whole inverse can be defined by 1 over determinant of AB into adjoint of AB. Therefore, first we will find what about the value for determinant of AB. Now determinant is nothing but 0 minus 6 8 minus 4. Get cross multiply. Left diagonal is 0 minus right diagonal 6 into 8. Minus of minus is nothing but plus 48. So it will be equal to 48. And it's also not equal to 0. Then adjoint of AB. Adjoint of AB. So by using in a shortcut form of how to find the adjoint of the matrices by using in the 2 cross 2 elements. So first will what are the elements of the left diagonals are will be interchanged. The elements of left diagonals are interchanged and right diagonals are changes with the sign. 6 minus 8. Therefore AB whole inverse can be written as 1 divided by determinant of AB into adjoint of AB. That is 1 divided by determinant of AB is 48 into adjoint is minus 4 6 minus 8 0 and let be called as an equation 1. Then we will be consider in their RHS B inverse into A inverse. Now first we will consider determinant of B. So determinant of 1 minus 2 3 0. So what are diagonal elements are? Left diagonal is 0 minus of minus is plus 6. Therefore 0 plus 6 is equal to 6. It's not equal to 0. That is the values of determinant of B. Therefore adjoint of B. Then we will consider adjoint of B. Now what are the left diagonals of the elements of B are interchanging with their position and right diagonals are changes with their sign. Left diagonals are interchanging their position and right diagonals are changes with the sign. Therefore B inverse can be written as 1 divided by determinant of B into adjoint of B. That is 1 divided by 6 into adjoint is 0 2 minus 3 1. Similarly, now to find the inverse of A. So first we will consider determinant of A. So determinant of A is nothing but 3 minus 1 2 2. Product of left diagonals are 6 minus right diagonal is minus 2 minus into minus is plus 2 6 plus 2 is 8. Then adjoint of A. Again, what are the left diagonals are interchanging in their position and right diagonals are differ with the negative. Therefore, adjoint of A is 2, 1, minus 2, 3. Therefore, A inverse is equal to 1 over determinant of A into adjoint of A. That is 1 over determinant of A is 8 into adjoint is 2, 1, minus 2, 3. These are the elements of A inverse. Then we will consider B inverse into A inverse. In the right hand side, terms of the right hand side, B inverse into A inverse. Now first we will elements of B inverse is 1 over 8 of 0, 2, minus 3, 1 into A inverse is nothing but 1 by 6 of. So 1 by, we will make it correction of B inverse. So B determinant of B is nothing but 6. So 1 by 6 of 0, 2, minus 3, 1 into A inverse is nothing but 1 over 8 of 2, 1, minus 2, 3. So first we will get multiply these two scalar number. 1 over 6 into 1 over 8 is nothing but 1 divided by 48. After then these two elements of the matrices are multiplied with the corresponding rows and column. First row, first column, 2 into 0 is 0, 2 into minus 2 is minus 4. Again first row, second column, 0 into 1 is 0, plus 3 into 2 is 6. Second row, first column, minus 3 into 2 is minus 6, plus 1 into minus 2 is minus 2. Second row, second column, minus 3 into 1 is minus 3, plus 1 into 3 is 3. That is 1 divided by 48 of 0 minus 4 is minus 4, 0 plus 6 is 6, minus 2 minus 6 is minus 8, minus 3 plus 3 is 0. And let be called as an equation 2. Then what are the elements of A and B are comparing with each other? Both LHS is equal to RHS. Comparing in equation 1 and 2, therefore AB whole inverse is nothing but B inverse into A inverse. That is one of the given results. Next one, if A equals 0, minus 1, 2, minus 1 and B is 1, 2, 3, 4, then to prove that AB whole inverse is equal to B inverse into A inverse. Now again first we will consider A into B. Elements of A and B are get multiplied with their correspondings. First row, first column, 1 into 0 is 0, minus 1 into 3 is minus 3. Again first row, second column, 2 into 0 is 0, minus 1 into 4 is minus 4. Now second row, first column, 2 into 1 is 2, minus 1 into 3 is minus 3. Second row, second column, 2 into 2 is 4, minus 1 into 4 is minus 4. That is 0 minus 3 is minus 3, 0 minus 4 is minus 4, 2 minus 3 is minus 1, 4 minus 4 is 0. Then we will find determinant of A into B. That is determinant of minus 3, minus 4, minus 1, 0. So product of left diagonals are 0. Minus right diagonal is minus into minus is plus 4, plus into minus is minus 4. That is 0 minus 4 is minus 4 and it is not equal to 0. Then we will adjoint of A into B. Adjoint of A into B. First we will interchanging what are the elements of the left diagonals. Minus 3, 0 are interchanging in their position. And right diagonals are multiplied by minus. That is an adjoint of AB. Therefore, AB whole inverse is equal to 1 over determinant of AB into adjoint of AB. That is 1 divided by determinant of AB is minus 4, otherwise it's also can be written as minus 1 divided by 4 into adjoint is 0, 4, 1, minus 3, and let be called as an equation 1. Then we will consider B. Now first we'll whatever the values of determinant of B. So determinant of 1, 2, 3, 4. Left to diagonal is 4, minus right to diagonal is 6, 4 minus 6 is minus 2. Then adjoint of B. Adjoint of B. So what are the left to diagonals are interchanging in their position and right to diagonals are differ with the negative. Therefore, B inverse is equal to 1 over determinant of B into adjoint of B. 1 over determinant of B is nothing but minus 2, that is minus 1 divided by 2 into adjoint of B is 4 minus 2 minus 3, 1. Similarly, now find the determinant of A. So determinant of elements of A are 0, minus 1, 2, minus 1. So left to diagonal is 0, minus right to diagonal is minus 2, minus into minus is plus 2. That is 0 plus 2 is equal to 2 is again not equal to 0. Then adjoint of A. Adjoint of A. So elements of left to diagonals are interchanging in their position, minus 1, 0, and right to diagonals are differ with the negative. Therefore, A inverse is equal to 1 over determinant of A into adjoint of A. Then 1 over determinant of A is 2 into adjoint is minus 1, 1, minus 2, 0. Now we will be consider B inverse into A inverse. Now elements of B inverse is minus 1 divided by 2 into 4 minus 2 minus 3, 1 into where A inverse is 1 over 2 of minus 1, 1 minus 2, 0. So minus 1 by 2 into 1 by 2 is nothing but minus 1 divided by 4 of. If these two matrices are multiplied with each other, first row, first column, 4 into minus 1 is minus 4, minus into minus is plus, 2 into 2 is 4. First row, first column. Then first row, second column, 1 into 4 is 4, minus 2 into 0 is 0. Then we will come to the second row. Second row, first column, 3 into minus 1 is plus 3, 1 into minus 2 is minus 2. Again second row, second column, minus 3 plus 0. That is minus 1 divided by 4 of minus 4 plus 4 is 0, 4 minus 0 is 4, 3 minus 2 is 1, minus 3 plus 0 is nothing but minus 3. And let be called as an equation 2. So after then we will comparing their elements of equation 1 and 2, both are will be equal. Therefore A into B whole inverse is equal to B inverse into A inverse. Next one, if A equals 3, 1, minus 2, minus 1, 2, then show that A square minus 5A plus 7I equal to 0 and hence to find A inverse. So these types of equations is already solving in their previous exercise, and inverse is also possible to solve by using the condition of determinant with adjoint. But in these problems, we will be using that equation how to find the inverse of the function, not by using the formula for 1 over determinant of A into adjoint. So inverse again formula gottide adana use madodana bittu by using their equation can be deduced in terms of inverse of a matrices. Now first we will solving that equation. Consider A square, where A square is nothing but A into A. Elements of A, 3, 1, minus 1, 2 into 3, 1, minus 1, 2. So first row, first column, 3 into 3 is 9. First row, second column is into minus 1. Again first row, second column, 3 plus 2. Now second row, first column, minus 3, minus 2. Second row, second column, minus 1 plus 4. These are 8, 5, minus 5, 3. That is an element of A square. Next with 5 into A means if all the elements of A are multiplied by 5. 5 3s are 15, 5 1s are 5, 5 into minus 1 is minus 5, 5 2s are 10, and 7 into I is nothing but I is an identity matrix of order 2 cross 2. After 7 is get multiplied, that is 7 0 0 7. Then we'll consider the left hand side of the given equation, A square minus 5A plus 7I. Now elements of A square are 8, 5, minus 5, 3, minus elements of 5 into A, 15, 5, minus 5, 10, plus 7 into I, 7, 0, 0, 7. So after get simplification of these three matrices, corresponding elements of first place are 8, minus 15, plus 7. Second elements are 5, minus 5, plus 0. In the second row, minus 5, minus into minus is plus 5, plus 0. Last element is 3, minus 10, plus 7. So get simplify. If all these elements of that matrix will be 0, it's one of the 0 matrix is denoted by 0. Therefore, A square minus 5A plus 7I is equal to 0. That is one part of the result. After that, by using that equation, how to find the inverse of A matrices. We will consider the equation A square minus 5A plus 7I equal to 0. If it is multiplied by A inverse on both sides of that equations, multiplied by A inverse on both sides of the given equation, that is A square into A inverse minus 5 into A inverse plus 7 into I into A inverse, it will be equal to 0. It means if all the elements of the given equations are get multiplied by A inverse. So after that we will get simplified A square into A inverse. But if these two terms are having in the same basis, then their power should be added. After additions of this power, minus 2 plus 1 is nothing but plus 1. That can be written as A. A square into A inverse is A power of 1. But A power of 1 is just written as in the form of A. Similarly, 5 into A inverse. A inverse is nothing but I. It's one of the definition of inverse of A matrices. A into A inverse or A inverse into A, it's always nothing but I. Therefore, A into A inverse is equal to I plus 7 into I into A inverse. Now, I is one of the identity matrix. A inverse is one of the matrices. After multiplications of any matrices with their identity, it's always one of the itself. Therefore, I into A inverse is nothing but A inverse. It will be equal to 0. Therefore, such an equation can be solved in terms of A inverse. 7 A inverse can be taken as in their one side and remaining 2 terms can be transposed into another side. That is 7 into A inverse is equal to 5I minus A. That is 5 into 1001 minus A is nothing but 3 1 minus 1 2. So 5005 minus 3 1 minus 1 2. So get subtracting their corresponding element. 5 minus 3 is 2. 0 minus 1 is minus 1. 0 minus of minus 1 is plus 1. 5 minus 2 is 3. These are the elements of 7 into A inverse. Therefore, A inverse is equal to 1 over 7 of 1 divided by 7 of 2 minus 1 1 3. These are the inverse of the matrix A. So it's one of the method using the given equation on how to find the inverse of the matrices. So it's also using in the shortcut method. So answer is nothing but C. Just we'll verify the given equations. So what out there? Determinant of A. ಇದು ನಿಮ್ಮ ವೆರಿಫಿಕೇಷನ್ಗೆ ಅಷ್ಟೇ. ಇಲ್ಲಿ ನಾವು ಇನ್ವರ್ಸ್ನ ಸಾಲ್ವ್ ಮಾಡಿ ಆಗಿದೆ, ಬಟ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಸಸ್ ಆನ್ಸರ್ ಕರೆಕ್ಟ್ ಇದೆಯಾ ಅನ್ನೋದನ್ನ ಜಸ್ಟ್ ವೆರಿಫೈ ದಿ ಶಾರ್ಟ್ಕಟ್ ಫಾರ್ಮ್. ಸೊ ಲೆಫ್ಟ್ ಡಯಾಗನಲ್ ಈಸ್ 6, ಮೈನಸ್ ಆಫ್ ಮೈನಸ್ ರೈಟ್ ಡಯಾಗನಲ್ ಈಸ್ 1. So 6 plus 1 is 7, that is 1 divided by 7 of 4. What are the elements of the left diagonals are 3, 2 or will be interchanging their position 2 and 3, and right diagonals are changes with their sign minus 1 plus 1. If it is comparing with the answers of inverse, so inverse in answer jothe adannu compare ಮಾಡಿ ನೋಡಿ, both are will be same. Therefore it's a one of the method how to find the inverse of a matrices, but it's also one of the method by using the given equations of the polynomial equations how to find the inverse of a matrices. Next one, if A equals 1 1 1 1 2 minus 3 2 minus 1 3, then show that A cube minus 6A square plus 5A plus 11I is equal to 0, and hence to find A inverse. Again, first we'll verify their equation. First we'll find the elements of A square. A square is nothing but A into A. 1 1 1 1 2 minus 3 2 minus 1 3 into 1 1 1 1 2 minus 3 2 minus 1 3. So first row first column, 1 into 1 is 1, 1 into 1 is 1, 1 into 2 is 2. First row second column, 1 into 1, 1 into 2, 1 into minus 1. First row third column, 1 minus 3 plus 3. Then we'll come to the second row. Second row first column, 1 plus 2 minus 6. Second row second column, 1 4 plus 3. First row third column, 1 minus 6 minus 9. Similarly for third row first column, 2 minus 1 plus 6. Third row second column, 2 minus 2 minus 3. Third row third column, 2 plus 3 plus 9. So get adding all these elements of the matrices. 2 1 plus 1 plus 2 is 4. Plus 1 minus 1 get cancelled, 2. Plus 3 minus 3 get cancelled, 1. 1 plus 2 is 3. 3 minus 6 is minus 3. 4 plus 1 is 5. 5 plus 3 is 8. 1 minus 6 is minus 5. Minus 5 minus 9 is minus 14. 2 minus 1 is 1. 1 plus 6 is 7. Minus 2 plus 2 get cancelled is minus 3. 2 plus 3 is 5. 5 plus 9 is 14. These are the elements of A square. Then we'll consider A cube. A cube is nothing but A square into A, where A square is 4, 2, 1, minus 3, 8, minus 14, 7, minus 3, 14. Into A is 1, 1, 1, 1, 2 minus 3, 2 minus 1, 3. Again first row, first column, 4 into 1 is 4, 2 into 1 plus 1 into 2. First row second column, 4 plus 4 minus 1. First row third column, 4 minus 6 plus 3. Then second row first column, minus 3 plus 8 minus 28. Second row second column, minus 3 plus 16 plus 14. Minus 3, 16 plus 14. For second row third column, minus 3 minus 24 plus 42. Sorry, minus 42. Then First row, third row, first column, 7 minus 3 plus 28. 7 minus 6 minus 14. 7 plus 9 plus 42. So 4 plus 2 is 8. 8 minus 1 is 7. 4 minus 6 is minus 2. Minus 2 plus 3 is 1. Minus 3 plus 8 is, minus 28 plus 8 is minus 20. Minus 20 minus 3 is minus 23. So 16 plus 14 is 30. 30 minus 3 is 27. Minus 3 minus 42. 42, 24, 3. Minus 69. So minus plus 7 minus 3 is 4. 4 plus 28 is 32. 7 minus 6 is 1. 1 minus 14 is minus 13. So 42 plus 9 is 51. 51 plus 7 is 58. These are the elements of A cube. Then we will substitute these elements of A square, A cube and A in their given equation. Now first we will consider elements of left hand side of the given equation. A cube minus 6A square plus 5A plus 11I equal to 0. Now A cubes are 8, 7, 1, minus 23, 27, minus 69, 32, minus 13, 58. Minus 6 into A square means what are the elements of A square are multiplied by 6. 6 into 4. 6 into 2. 6 into 1. 6 into minus 3. 6 into 8. 6 into 14. 6 into 7. 6 into 3. And 6 into 14. That is minus 84. Plus 5 into A means if all the elements of A are multiplied by 5. 5, 5, 5, 5, 10, minus 15, 10, minus 5, 15. That is 5 into A plus 11 into I. 11 into I, where I is an identity matrix of order 3 cross 3, 11, 0, 0, 0, 11, 0, 0, 0, 11. So get adding their corresponding element. First elements are 8 minus 24 plus 5 plus 11. Second elements are 7 minus 12 plus 5 plus 0. Third element is 1 minus 6 plus 5 plus 0. Second row, minus 23 minus into minus is plus 18 plus 5 plus 0. Second plus 27 minus 48 plus 10 plus 11. Third plus minus 69 minus into minus is plus 84 minus 15 plus 0. Third row 32 minus 42 plus 10 plus 0 minus 13 minus into minus is plus 18 minus 5. Last one is 58 minus 84 plus 15 plus 11. So once we'll check whether if all the elements after either addition or then subtraction is nothing but 0. Therefore, in the LHS of the given equation is a cube minus 6a square plus 5i plus 5a plus 11i is equal to 0. That is one part of the given condition. Then by using that equation to find the inverse of the matrices, means find an A inverse of that elements of the matrix. Now consider a cube minus 6a square plus 5a plus 11i is equal to 0. After that equation are get multiplied by a inverse. A cube into a inverse is nothing but a square minus 6 into a square into a inverse is nothing but a plus 5 into a inverse is nothing but I plus 11 into I into a inverse is nothing but a inverse. It will be equal to 0. Means if all the elements of the given equations is multiplied by a inverse, a cube into a inverse is a square. So we will reducing in one terms of the given power. A square into a inverse is a into a inverse is I into a inverse is nothing but a inverse. So after that in terms of inverse are in their one side and remaining terms of their equations are can be transposed into another side. That is minus a square can be taken as in the second place 6a minus a square minus 5i. 6a will be positive can be taken as in their RHS, a square will be negative minus 5a. After then we will get substitute that values. 6 into a means if all the elements of a are multiplied by 6. 12 minus 18, 12 minus 6, 18. These are the elements of 6a. Means if all the elements of a are multiplied by 6 minus a square. So what are the elements of a square? So a square are 4, 2, 1, minus 3, 8, minus 14, 7, minus 3, 14. Plus minus 5 into a. So I is an identity matrix of order 3 cross 3, that is 5, 0, 0, 0, 5, 0, 0, 0, 5. So get subtracting their corresponding elements of all the matrices. Now the first elements are 6, 6 minus 4 is 2, 2 minus 5 is minus 3. Otherwise minus 5 minus 4 is minus 9, minus 9 plus 6 is minus 3. Second element 6 minus 2 is 4. Third element 6 minus 1 is 5. In second row 6 minus half minus 3 is plus 3, 6 plus 3 is 9. 12 minus 8 is 4, 4 minus 5 is minus 1. 18 minus 18 plus 14, minus into minus is plus 14, minus 18 plus 14 is minus 4. Third row 12 minus 7 is 5. Minus 6 minus into minus is plus 3, minus 6 plus 3 is minus 3. 18 minus 14 is 4, 4 minus 5 is minus 1. Now these are the elements of 11 into A inverse. Therefore A inverse is nothing but 1 divided by 11 of minus 3, 4, 5, 9, minus 1, minus 4, 5, minus 3, minus 1. These are the inverse of the given matrix A. So, idunu ನೀವು ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಮೆಥಡಲ್ಲಿ ವೆರಿಫೈ ಮಾಡ್ಬೋದು. ಇಟ್ಸ್ ಒನ್ ಆಫ್ ದಿ ಫಾರ್ಮುಲಾ ಫಾರ್ 1/, ಡಿಟರ್ಮಿನೆಂಟ್ ಆಫ್ ಎ ಇಂಟು ಅಡ್ಜಾಯಿಂಟ್ ಆಫ್ ಎ. ಬೋತ್ ಆರ್ ವಿಲ್ ಬಿ ಸೇಮ್ ಬಟ್ ದ ಮೆಥಡ್ ಆರ್ ವಿಲ್ ಬಿ ಡಿಫರೆಂಟ್. ನೆಕ್ಸ್ಟ್ ಒನ್, ಫಾರ್ ದಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಎ ಈಕ್ವಲ್ಸ್ 3, 2, 1, 1, find the numbers a and b. Means a and b are the some scalar number such that a square plus A into A plus BI is equal to 0. Now first we will consider in their equation to find the values elements of A square. A square is nothing but A into A, that is 3 to 1 1 into 3 to 1 1. So multiplied with rows and column. First row, first column, 3 3s are 9 plus 1 into 2. Again first row, second column, 6 plus 2. Second row, first column, 3 plus 1. Second row, second column, 2 plus 1. That is 11, 8, 4, 3 are the solutions of A square. Then we will consider the equation A square plus A into A plus B into I is equal to 0. Will be considered in both LHS and then RHS. Now substitute their elements of A square. 11, 8, 4, 3 plus A into A means small a is represented for the scalar number, capital A is represented some matrices. So A into A means if all the elements of the matrix A, it's multiplied by small a. After that multiplication, these are elements that are nothing but 3A, 2A, 1 into A is nothing but A, again 1 into A is nothing but A, plus B into I, where I is an identity matrix of order 2 cross 2, after that B is get multiplied, that is B 0, 0, B. It will be equal to 0. Now get adding their corresponding element 11 plus 3A plus B. Second elements are 8 plus 2A plus 0. Second row 4 plus A plus 0, 3 plus A plus B is equal to 0. In their RHS, it's one of the 0. 0 can be represented in terms of matrices. It also can be written as 2 cross 2 matrix of the 0 matrices. So after then we will comparing the elements, corresponding elements of both LHS and then RHS. Now these two are in the form of equalities of two matrices, therefore equating their corresponding elements. In the first elements are 11 plus 3A plus B is equal to 0. Similarly second one is 8 plus 2A is equal to 0. So similarly these are also possible to comparing with each other, but if these are not necessary because which contains some two constants, only for two constant A and B. Both are represented in some two different equations. So we will get solving. 8 plus 2A is equal to 0, therefore 2A is equal to minus 8, then A is equal to minus 4. Similarly, now such a values of A can be substituted in that equation. In another one of the equation, put A is equal to minus 4, 11 plus into minus is minus, 3 into 4 is 12 plus B is equal to 0. So 11 minus 12 is minus 1, minus 1 plus B is equal to 0, therefore B is equal to 1. Therefore, the values of A is equal to minus 2 and B is equal to 1. These are the some values of the scalar numbers. Next one. These are some multiple questions and also one more question for in our annual examination. Let A be a non-zero square matrix of order 3 cross 3. And these are also not necessary to mention. It's also just mentioned with the order of matrix of order 3. So 3 is represented as one of the square matrix of order 3 cross 3. Then find adjoint of, determinant of adjoint of A. So we will already discuss some one of the formula for what about the determinant of adjoint of A. In the yesterday classes we will already discuss some properties on the basis of adjoint. So what about the determinant of adjoint of A? That is determinant of A all to the power of n minus 1. We will already know that the result. Determinant of adjoint of A is equal to determinant of A all to the power of n minus 1. But what about the n, where n is called the order of the matrix. So in the given matrix, what about their order is nothing but 3. Therefore, n is equal to 3. Therefore, it can be written as determinant of A whole to the power of 3 minus 1. It's also can be written as determinant of A square. So determinant of adjoint of A is nothing but determinant of A whole square. Suppose ನೋಡಿ ಇದೇ ಪ್ರಾಬ್ಲಮಲ್ಲಿ ಸಮ್ ಆಫ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ಡಿಟರ್ಮಿನೆಂಟ್ಸ್ will be given. Determinant of A ವ್ಯಾಲ್ಯೂಸನ್ನು ಕೊಟ್ಟಿದ್ರೆ so we'll get substitute that values. So we'll be discussing the next problem. Next one is, if A is an invertible matrix of order 2, then to find determinant of A inverse. So determinant of A inverse is nothing but 1 over determinant of A. It's one of the formula to find the determinant of A inverse. So determinant of A inverse is nothing but 1 over determinant of A. It's also to remember that formula. It's one of the shortcut formula for the purpose of competitive exams. Now next one is, if A is equal to 1, 2, 3, 4, it's one of the 2 cross 2 matrices. Now to find determinant of A inverse. So if one of the method is possible, first then elements of A inverse. A inverse is nothing but 1 over determinant of A into adjoint of A. After then we'll find the values of determinant. But if these are not necessary to by using the procedure, because it's a 1 mark question for in our examination, therefore it's by using the formula for determinant of A inverse is nothing but 1 over determinant of A. Therefore first we'll find the elements of determinant of A. Determinant is 1, 2, 3, 4. Left diagonal is 4, minus right diagonal is 6, that is minus 2. Therefore determinant of A inverse is equal to, either it's denoted by symbol, otherwise by using the letters. Determinant of A is nothing but 1 over determinant of A, that is 1 divided by minus 2, otherwise it's also can be written as minus 1 divided by 2. So that is the values of the determinant of A inverse. Next one, if A is a square matrix of order 3 and determinant of A is equal to 4, then to find determinant of adjoint of A. Now first by using the formula for determinant of adjoint of A, it's nothing but determinant of A whole to the power of n minus 1, where n is called the order of the matrices. So in the given problem, whatever the order of the given matrix is 3. Therefore determinant of A whole to the power of 3 minus 1. But it's also given that whatever the value for the determinant of A. So determinant of A is 4 whole to the power of 3 minus 1 is 2. Therefore 4 square is equal to 16. That is the values of determinant of adjoint of A. So similarly, next one is, if A is equal to 1, 3, 5, 6, find the determinant of adjoint of A. And first we'll comparing these two problems. In the last problem we will directly given us whatever the value for the determinant of A. It's one of the possibility. ಆ ಥರನೂ ಕ್ವಶನ್ನ ರೈಸ್ ಮಾಡ್ಬೋದು. ಅದರ್ವೈಸ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ದಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆರ್ ಇನ್ ದ ಗಿವನ್ ಇನ್ ದಿ ಫಾರ್ಮ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಸಸ್ನ ಎಲಿಮೆಂಟ್ಸ್ ಫಾರ್ಮೇಷನಲ್ಲಿ ಕೊಟ್ಟು ಹೌ ಟು ಫೈಂಡ್ ದಿ ಅಡ್ಜಾಯಿಂಟ್, ಡಿಟರ್ಮಿನೆಂಟ್ ಆಫ್ ಅಡ್ಜಾಯಿಂಟ್. ನಾವು ಫಸ್ಟ್ ವಿಲ್ ಫೈಂಡ್ the determinant of A, where A is equal to 1, 3, 5, 6. Now determinant of A is equal to, left diagonals are 6 minus right diagonal is 15. So 6 minus 15 is nothing but minus 9. So that is the value for determinant of A. So after then by using the formula, determinant of adjoint of A is equal to determinant of A whole to the power of n minus 1, where n is called the order of the matrices. So first we'll whatever the order of the given matrix is 2 cross 2. Therefore determinant of A is minus 9 whole to the power of 2 minus 1. So 2 minus 1 is nothing but 1. Therefore it will be equal to minus 9. Therefore determinant of adjoint of A is equal to minus 9. Next one is, if A is a square matrix of order 2, then and determinant of A is equal to 2, then to find determinant of A into A dash. Now determinant of A into A dash is also can be written as determinant of A into determinant of A dash by using one of the properties of adjoint determinant of A into B can be written as determinant of A into determinant of B. We'll already know that result. So by using that result, determinant of A into A dash can be written as determinant of A into determinant of A dash. But what about the differences between these two determinants? So one of the given matrices and another one is the transpose of the matrices. A is a given matrices, then A dash is called the transpose of the matrices. But what about the values of the determinant? Because one of the determinant of A R will be given, but it's not particularly mentioned for A dash. So ನಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋದು ಡಿಟರ್ಮಿನೆಂಟ್ ಆಫ್ ಎ ಮಾತ್ರ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎ ಡ್ಯಾಶ್ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಆಗಿಲ್ಲ. ಹಾಗಾದರೆ ವಾಟ್ ಅಬೌಟ್ ದ ವ್ಯಾಲ್ಯೂ ಫಾರ್ ಡಿಟರ್ಮಿನೆಂಟ್ ಆಫ್ ಎ ಡ್ಯಾಶ್? Now determinant of A dash and A R also will be equal. Determinant of A, it's also equal to determinant of A dash, means it's one of the properties of the determinant. So if all the elements of rows and columns are interchanged, then the values of the determinants are does not alter. Therefore A and A dash are always should be equal. So what about the value for A is 2 into A dash is also 2. 2 into 2 is equal to 4. Therefore determinant of A into A dash is equal to 4. These are the some problems on the basis of multiple choice question, because it is also one mark question for even our annual examination. So dear students, so test will be conducted in the end of this week. So sir is told that give there some information about the test, but now can be discussed some pattern of question paper. So test ಗೆ ಕ್ವಶನ್ ಪೇಪರ್ನ ಪ್ಯಾಟ್ರನ್ ಯಾವ ಫಾರ್ಮೇಷನಲ್ಲಿ ಇರುತ್ತೆ ಅನ್ನೋದನ್ನ ಸ್ವಲ್ಪ ಡಿಸ್ಕಷನ್ ಮಾಡಿ ಜಸ್ಟ್ ಇನ್ 2 minutes. ಸೊ ಫಸ್ಟ್ ಮೈನ್ it's an 1 mark question. First main is a 1 mark question. So 5 questions are will be given, all are compulsory. 5 questions, all are will be compulsory. There is no choices in the first main 1 mark question. Second main 2 mark question, each question carrying 2 marks. Each question carrying 2 marks. 5 can be choosing out of 6. 5 can be choosing out of 6 question. 1 questions are will be choosing. So that is 2 into 5 is equal to 10. 1 mark question is 1 into 5 is equal to 5. 1 into 5 is equal to 5. So in the second main, each question carrying 2 marks, out of 6 will be choosing only 5 question, that is 2 into 5 is 10. Third main, each question carrying 3 marks. Each question is carrying 3 marks. Again 5 can be choosing out of 6 question, that is 3 into 5 is equal to 50. 3 into 5 is 50. And the fourth main, each question carrying 5 marks. Each question carrying 5 marks. So 4 out of 5. 4 out of 5, that is 5 into 4 is equal to 20. So therefore total marks will be 50 marks. 20, 35, 45 plus 5 is 50 marks. These are the pattern of the question paper. In the first main 1 mark question, all are compulsory. Second main, to each questions carrying 2 marks. So 5 can be choosing out of 6 questions. So third main is each question carrying 3 marks. Again 5 can be choosing in out of 6 questions. And fourth main, so each question carrying 5 marks and 4 question can be choosing out of 5 questions. So total is 50 marks question paper.